Hi, welcome to Precalculus. Topic today is solving a trigonometric equation, modeling a real-world situation. Okay, so we had a few questions of this type during the semester, something modeling a real-world situation. The previous one was for rotational motion, and the formula that V is equal to R times angular velocity. So here is a bit more interesting question. It says, suppose that the height above the ground of a person sitting on a Ferris wheel is described by the following equation. H of t is equal to 18.6 minus 16.5 cosine of 2 pi t over 5. In this equation, h is the height above the ground in meters and t is the time in minutes. The ride begins at t equal to 0 minutes. During the first 5 minutes of the ride, when will the person be 27 meters above the ground? Do not round any intermediate computations and round your answers to the nearest hundredth of a minute. If there are more than one answer, enter additional answers with the OR button. Okay, there are two aspects to this problem. One is, well, what's the answer? Second question is, where does that formula itself come from? For your career in engineering and such, you want to take this problem seriously and go into deep end of it and not be satisfied just with finding some numbers. But let's first answer the question, and then the rest of that discussion is going to be for your own benefit. So, what's the idea? The idea is that, well, we have a Ferris wheel. So we have a Ferris wheel. And when you start your ride at the bottom, and you turn one way or another. The ones that I have seen, typically they turn counterclockwise. So we have an axis here, and the axis measures the height of the person from the ground. So here's our ground, and as you go around this circle, so suppose you go here, at each time you're at a different location, and then you come back and perhaps you go for a second round and such. So what is h? H is how high above the ground you happen to be. The problem is asking us, when is it that you're going to be a certain number of meters above the ground? Well, that means we want the height to be 27. So say here, say this is 27 meters above the ground. It's asking us at the time at which we are going to be that high up. So at what time do we reach this point? That would be our first encounter if we ever make it that far, that high. Then we go around and come down again and pass through the same height again and come back down. So it's likely that the problem is going to have two answers, and we're going to find that. So what is it that we want? We want the h of t, the height, to become 27. So we really have 27. It's going to turn out to be 18.6 minus 16.5 times cosine of 2 pi t over 5. So I bring 18.6 to this side, 27 minus 18.6, and that is minus 16.5 times cosine of the same argument. Well, do the subtraction, and then you get, I guess you get 8.4 Is that right? 8.4 is equal to minus 16.5 cosine of stuff. Well, what does that mean? That means that cosine of 2 pi t over 5 will be minus 16.5 over 8.4. Yeah, it gives us a little bit of a warning. Do not round any intermediate computations. So what that means is that if you divide this thing on your calculator, you're likely just to keep one or maybe at most 2 decimal places, and then at the end you could end up with shaving a little bit off of your answer and such. This is asking you to get your answer to the nearest hundredth of a minute. So one of two options: either if you use the calculator, write this thing to full number of decimal places, or just delegate this thing to your calculator, let it do the division and keep all the digits in the memory. So for that reason, I just leave this thing as it is. So it says do not round any intermediate computation, just so that we don't lose accuracy by dropping digits off. So how would we solve cosine equal to number? Suppose somebody asked me solve cosine of x is equal to a. What do I do? You remember we draw the unit circle. This would be a cosine axis, so the cosine axis is here. This being negative, it means suppose a is given to you as a negative. So you're on this side, you draw a vertical, and here are the two angles you are interested in the unit circle. Let me color them by white. Either you're going to that first position, or you're going here to this second position, one of these two. So what we are after there, here our picture turns to the side, because that's how we drew the unit circle a long time ago. So what do we do here? Let's call this first angle, let's call it theta. That's what your calculator reports back to you. That's going to be arc cosine of a. Whatever we have, theta will be arc cosine of a. Let me call this thing solution number 1. How about the solution number 2? What is the other one? Well, subtract that from 2 pi and you get theta 2. So 2 pi minus arc cosine of a will be the second answer that you have. So here 2 pi t over 5, either take arc cosine of minus 16.5 over 8.4. That is, so the angle that we find here is 2 pi t over 5, and then t itself is going to be 5 over 2 pi. So I multiply by 5, divide by 2 pi, times arc cosine of minus 16.5 over 8.4. How about the other answer? So other possibility is 2 pi t over 5 is equal to 2 pi. So instead of arc cosine, I could have 2 pi minus arc cosine of minus 16.5 over 8.4, multiplying by 5 and dividing by 2 pi, exactly just like here. T becomes, so I had a 2 pi here, multiply by 5, divide by 2 pi, and then subtract, same thing, 5 divided by 2 pi of arc cosine of minus 16.5 over 8.4. So these 2 pi's cancel, and t that I get is going to be 5. So it's going to be This is solution 1. Solution 2 is 5 minus 5 over 2 pi. Same thing. Now it would be a good thing to check if your software actually accepts this thing at all or not, or does it actually insist on giving the answer to 2 decimal places. Either way, you can enter it or type it on a calculator, round to 2 decimal places, so that you get the answer to nearest hundredth of a minute, and then you're all done. So this was the description of the solution. Okay, and this was the solution of the problem. So we had to get a grip on what is actually the problem is referring to. So a real world problem, we always have an interpretation of what is it that the author meant, what is it that the problem is talking about. So it always helps to have a picture and some understanding as to the meaning of the question itself. Okay, next level up is the question of where does this type of a formula come from? What are the meanings of that are implied by it? How does that relate to what we have here? So some components that will indicate our understanding. For example, where is the lowest point? Where is the highest point? Where are these midpoints? What's the radius of the circle? What's the diameter of the circle? At what rate do we turn around? How long does it take for us to go into the circle and come back? How fast does the Ferris wheel turn? All sort of question of this type could be asked, and then you want to kind of grapple with the problem so that it becomes understandable. In that case, you can say, well, I dealt with a real world situation. Mathematics of setting up an equation and solving it, that's one thing. Understanding what does it talk about is entirely different story. So when you go to calculus, well, bulk of calculus will be lots of questions related to functions, their properties. You're going to do things called differentiation, integration, and so on. But then there are some sections that, again, they are going to insist on real-world problems, and they tend to be kind of challenging for most students because of lack of practice. So you want to take this opportunity to familiarize yourself with the situation and become comfortable with this. Not only it makes mathematics enjoyable, also it makes certain sections of calculus to be doable for you. So in calculus, you are going to have sections called, for example, optimization or related rates and question of that type. There are 2 challenging sections there, and they are all related to so-called real-world problems. So typically, a verbal description of some situation is given. You have to create your own formulas typically and also analyze them. So let's take the issue one at a time. So the rest of this conversation here is going to be just additional explanation. Is not required anything. Here we are done with this problem. This is first time, and the second time you just enter it in your calculator and then you'll be all done. So issue number 1. Here's a Ferris wheel. So it's a circle. What's the radius of it? Sorry. So what is the radius? You remember from the section that we had with the graph of trig functions. This is the radius. Radius is 16.5. Taking that, multiplying by cosine or sine, it's gonna let you go around. So that we used to call that the amplitude before. Now it's changing to radius. What is the lowest point here? Lowest point, well, we said we are starting the right at time t equal to 0. Stands to reason that we start from here. At time equal to 0, cosine becomes the maximum amount is going to be, which is 1. 1 times 16.5. Subtract from 18.6. So our lowest point is going to be 18.6 minus 16.5. So that's going to be, what's that, 2.1. So at the moment that you are going to take your seat in the Ferris wheel, you are 2 meters above the ground according to this problem. It's going to be, of course, there's got to be some sort of a platform or something here that you go above it, and then you enter that. So 2.1, that's about 7 feet high. So you have to consider that the engineering aspect of this perhaps takes the wheel substantially above the ground. Okay, that's the low point. Here's the where's the high point of this thing? So high point, when cosine becomes -1, that is when the argument of it becomes pi, you have traveled pi radians, you reach the highest point. So it's going to be 18.6 plus 16.5. So that's going to be, what's that, 35.1, is that right? 35.1, I guess that's in meters. You want in feet, almost multiplied by 3, so almost 110 feet high. So it's going to be quite quite high. Next question we can ask, well, what's the rightmost point? The rightmost point would be same as the radius. So we are going to, sorry, so this is going to be 16.5 to the right, and then we are going to 16.5 to the left. That is how far to the right and left we are going to go. Next question is, how long does it take for the ride? Until you come back. So you go all around, come back here. How long has passed? Well, that all depends on what's inside this argument of cosine. For cosine to go through a full cycle, its input has to go through a range of 2 pi. So at time t equal to 0, we are at this location. By the time we make it back here, our angle has gone through a 2 pi radians, that is 2 pi 5 times t, has to become 2 pi. This is going to be a one round. One round means the argument of your trig function, sine or cosine, has gone through a range of 2 pi. So what does that mean? You multiply by 5, divide by 2 pi, you get t equal to 5 minutes. So this ride takes 5 minutes. From my experience, that sounds like a very slow ride. Like you're really taking your sweet time going around. 5 minutes to take the whole circle looks kind of very slow. At any rate, so if you have a some number minus b some number cosine of some number times t, that's an example of the height of a function that represents going on a circle. Okay, in your physics classes, this is going to be referred to as a simple harmonic motion. Simple harmonic motion is a kind of motion that imitates going in circles. And then all the details we talked about, you will be interested in that. So t equal to 5, this is going to, previously we called this thing period. period means the length of time it takes for something to repeat itself. So you started at here, you go around, by the time you come back here, you're starting the game all over again. That time is called the period. Okay, so we had a little bit of additional discussion here. You might have a separate problem of this nature added to your homework list, and that should be interesting. So until next time, good luck and God bless.